So now let us see configurational work done in a cyclic process. So here I have written configurational work done. Now onwards I will simply write work done. I won't write this term. So unless it is dissipative work done, I will always use work done for configurational work done. If it is dissipative work done, I will mention it dissipative work done. So let us see, this is a cyclic process. So PV diagram, this is indicator diagram, and we have a cyclic process like this. So here the cyclic process is like this, and we want to know that the system is doing what type of system it is. Let us analyze this. So we will select two paths. This is point A and B at extreme ends. This is path 1 and this is the path 2. So by path 1 it is going from A to B, by path 2 it is coming. So you see, let us see each path separately. So this is A to B via path 1. So you see here the gas is doing some work because the volume is increasing, and the amount of work done by gas is area under this curve. So here work is done by the system. The system is doing some positive work, and how much work is done by the system? The area under this curve. Now come B to A. So when we come from B to A, this is B to A, this is the path 2, then the area under the curve is this much. So here you come from B to A, and here I was going from A to B. So when you come from B to A, the work done is the area under this curve, and you see this B to A, the volume is decreasing, the system is not doing work, work is done on the system. So how much work? The area under curve is the work done on the system. Here area under curve is work done by the system. So now you see, who is doing more work, this area or this area? This area obviously. So work done by the system is more, suppose 100 joule, and here it is 60 joule. So net work done is 40, and the net difference in area is this. So the work done, so in a cyclic process, the area under the curve in the cyclic process, the area under the cycle gives work done. Why? You see the difference of the area is the net work done. Now you see this is clockwise process, and you can see system is net work is done by the system. So if the process is clockwise, then the work done by the system is positive. You see, a system is doing some positive work, so such type of system is called an engine. So this is an engine. So clockwise processes are the processes of an engine. Engine, you know, the engine of a bike, any engine, the work of engine is to do some work. So net work is done by an engine, and its opposite is a refrigerator, where we have to do some work to extract heat from some food stuff. So this is the cyclic process, and now let us see its reverse order. Now let us see another cyclic process. This is PV, and this time we have a process anti-clockwise. So this is B and this is again A. So let us start with again the same. This is path 1 and this is path 2. So you see here, this is my PV diagram, and this is, suppose I start from A to B. This is A to B, I am going this way, this is by path 2. So my area under the curve is this, and the area under the curve is the work done by the system. You see, the volume expands while going from A to B. The volume expands, the system expands and expels air from its surroundings. As a result, it does positive work. The work is area under the curve. Now, then again, this is PV. So while coming from B to A, it has to follow path 1, and you see the area under the curve is this much. So the area under the curve gives the work done on the system. So here the external agency is doing work on the system, and that is the area under this curve. So which area is more? This. Thus the area under the cycle is the net work done on the system. So here the work is done on the system, which is large, so the net work done is on the system. So if there is a work done on the system, if we have a machine on which we are doing some work, this machine is a refrigerator type. So thus the area under the curve is this, the net work done on the system. Thus, if the cyclic process is anti-clockwise, then it represents a refrigerator. So we have two types of heat machines, engines and refrigerator. Refrigerator will be anti-clockwise and engines will be clockwise.